The disparity between the standard one-family dwelling calculation and optional method 220.30 is a well-known issue and has been a source of concern for many years. As you've observed, method 220.30 typically results in load estimates that are 50 to 60% lower than the standard method. There are several reasons for this difference. Firstly, appliance saturation. Method 220.30 assumes that not all appliances in a home will be used simultaneously, which reduces the total load. Secondly, diversity factors. The standard method uses fixed diversity factors for different appliances, while method 220.30 uses a demand factor that varies depending on the number of appliances. Thirdly, metering and data collection. Method 220.30 is based on actual metering data, which may not accurately represent the peak load. It's important to remember that the NEC is intended to provide minimum safety standards. The standard method is conservative and ensures that there is sufficient capacity to meet the potential load, even if all appliances are used simultaneously. Method 220.30, on the other hand, provides a more realistic estimate of the load, but there is a risk that the service may be undersized in some cases. The significant difference in load calculations can have a substantial impact on load center and service sizing. A smaller load estimate using method 220.30 may allow for a smaller load center and service, which can save money for the homeowner. However, it's crucial to ensure that the service is adequately sized to prevent overloading. Regarding recommendations for practitioners, firstly consider using method 220.30 for single-family dwellings. Method 220.30 can provide a more accurate estimate of the load for most single-family homes. Secondly, review load calculations carefully. Regardless of the method used, it's essential to review load calculations carefully and ensure that the service is adequately sized. Thirdly, consider conservative load calculations for large homes or complex systems. For larger homes or homes with complex electrical systems, it may be prudent to use the standard method to ensure sufficient capacity. Local inspectors may have specific guidelines or requirements regarding the use of method 220.30 in their jurisdiction. The National Electrical Code, or NEC, provides two primary methods for calculating the electrical service load for a dwelling unit. These methods are the standard method, as described in Article 220 of the NEC, and the optional method, specifically outlined in Section 220.30. The standard method is generally considered more conservative, while the optional method allows for a more realistic assessment of the actual load based on typical usage patterns. The standard method involves calculating the load for various components of the dwelling's electrical system, including general lighting and receptacle circuits, small appliance circuits, laundry circuits, and fixed appliances. A demand factor is applied to the general lighting and receptacle load based on the square footage of the dwelling. Each small appliance circuit is calculated at 1500 volt amps, and each laundry circuit is also calculated at 1500 volt amps. Fixed appliances, such as water heaters, ranges, and dishwashers, are calculated at their nameplate rating. The optional method, as described in Section 220.30 of the NEC, offers a simplified approach to calculating the service load for a dwelling unit. This method is often used for single-family dwellings and can result in a lower calculated load compared to the standard method. To use the optional method, you first need to determine the total connected load of the dwelling. This includes the load for general lighting and receptacle circuits, small appliance circuits, laundry circuits, fixed appliances, and any other loads connected to the electrical system. Once you have determined the total connected load, you can apply the demand factor specified in Section 220.30 of the NEC. These demand factors vary depending on the type of load and the total connected load. For example, the demand factor for the first 10 kilowatts of load is 100%, while the demand factor for the remaining load is 40%. After applying the demand factors, you will arrive at the calculated service load for the dwelling. This is the load that you will use to size the service entrance conductors and the overcurrent protection device. It's important to note that the optional method is not always applicable. It can only be used for single-family dwellings and must comply with all other requirements of the NEC. Additionally, some local jurisdictions may have specific requirements or restrictions on the use of the optional method. The standard method typically results in a higher calculated load compared to the optional method. This is because the standard method uses more conservative assumptions and does not take into account the diversity of loads that may be present in a dwelling unit. The optional method, on the other hand, allows for a more realistic assessment of the actual load based on typical usage patterns. This can result in a lower calculated load, which can save money on service entrance conductors and overcurrent protection devices. It is important to consult with the local electrical inspector or authority having jurisdiction to determine which method is appropriate for a particular installation. They may have specific requirements or preferences based on local conditions and practices. In addition to the standard and optional methods, the NEC also provides guidelines for calculating the load for specific types of equipment such as air conditioners, heat pumps, and electric vehicles. These guidelines can be found in Article 220 of the NEC and should be followed to ensure that the electrical system is properly sized and protected. When performing load calculations, it is essential to use accurate and up-to-date information. This includes the nameplate ratings of all appliances and equipment, as well as the square footage of the dwelling. It is also important to consider any future loads that may be added to the electrical system, such as additional appliances or electric vehicle chargers. Oversizing the electrical system can provide a margin of safety and allow for future expansion. However, it is important to avoid excessive oversizing, as this can lead to unnecessary costs and inefficiencies. Working closely with a qualified electrician or electrical engineer is essential to ensure that the electrical system is properly designed and installed. They can help you determine the appropriate load calculation method, select the correct service entrance conductors and overcurrent protection devices, and ensure that the electrical system complies with all applicable codes and regulations. The significant difference between the standard and optional methods for calculating residential electrical loads in the NEC stems from their differing approaches to accounting for load diversity and demand factors. This standard method generally assumes a higher degree of simultaneous use of various electrical loads within a dwelling, leading to a more conservative and often higher calculated load. The optional method, particularly section 220.30, allows for a more nuanced assessment of load based on the understanding that not all appliances and electrical equipment will be operating at their maximum rated load simultaneously. Here is a breakdown of the key factors contributing to the disparity. Firstly, demand factors. The standard method applies fixed demand factors to certain loads, such as general lighting and receptacle circuits, based on the square footage of the dwelling. These demand factors are intended to account for the fact that not all lights and receptacles will be in use at the same time. However, the standard method's demand factors are often more conservative than those used in the optional method. The optional method, as outlined in section 220.30, uses a different set of demand factors that are based on the total connected load of the dwelling. These demand factors are generally lower than those used in the standard method, reflecting the assumption that larger dwellings with more connected load will have a lower percentage of their loads operating simultaneously. Secondly, appliance diversity. The optional method recognizes that not all appliances within a dwelling will be used at the same time. This is particularly true for appliances with intermittent or cyclical operation, such as refrigerators, washing machines, and dishwashers. The optional method allows for a reduction in the calculated load based on the diversity of these appliances. The standard method, on the other hand, typically calculates the load for each appliance at its nameplate rating, without accounting for diversity. Thirdly, heating and cooling equipment. The optional method provides specific rules for calculating the load for heating and cooling equipment, such as air conditioners, heat pumps, and electric furnaces. These rules take into account the fact that heating and cooling equipment typically operates at less than its rated capacity for much of the year. The standard method, in contrast, may calculate the load for heating and cooling equipment at its full nameplate rating, which can result in a high calculated load. Fourthly, code conservatism. The NEC is intended to provide minimum safety standards for electrical installations. As such, the standard method is designed to be conservative and ensure that the electrical system has sufficient capacity to handle the potential load. The optional method, while still providing for safety, allows for a more realistic assessment of the actual load, which can result in a lower calculated load. Fifthly, local amendments. It's important to note that local jurisdictions may have amendments to the NEC that affect the way residential electrical loads are calculated. These amendments may require the use of the standard method in certain situations or may modify the demand factors used in the optional method. The implications of the difference between the standard and optional methods for residential electrical load calculations are significant. A higher calculated load, as determined by the standard method, will typically result in a larger service entrance, larger conductors, and a larger overcurrent protection device. This can increase the cost of the electrical installation. A lower calculated load, as determined by the optional method, can result in a smaller service entrance, smaller conductors, and a smaller overcurrent protection device. This can save money on the electrical installation. However, it's important to ensure that the electrical system is still adequately sized to handle the actual load. If the electrical system is undersized, it can lead to overloaded circuits, nuisance tripping of circuit breakers, and even electrical fires. Therefore, it's crucial to carefully consider the pros and cons of each method and to consult with a qualified electrician or electrical engineer to determine the appropriate method for a particular installation. The choice between the standard and optional methods for calculating residential electrical loads depends on a number of factors, including the size and complexity of the dwelling, the types of appliances and equipment that will be installed, and the local codes and regulations. In general, the optional method is more appropriate for smaller, simpler dwellings with a relatively low connected load. The standard method is more appropriate for larger, more complex dwellings with a higher connected load. However, it's important to carefully evaluate each situation on its own merits and to consult with a qualified professional to ensure that the electrical system is properly designed and installed. Here are some additional considerations when choosing between the standard and optional methods. Firstly, future expansion. If there is a possibility that the electrical load will increase in the future, it may be prudent to use the standard method to ensure that the electrical system has sufficient capacity. Secondly, energy efficiency. If the dwelling is designed to be energy efficient, with features such as energy efficient appliances and lighting, the optional method may be more appropriate. Thirdly, resale value. A larger electrical service may be seen as a selling point by some potential buyers, so it may be worth considering the standard method even if the optional method would result in a low calculated load. Fourthly, insurance requirements. Some insurance companies may have specific requirements for the size of the electrical service, so it's important to check with your insurance provider before making a decision. The NEC provides two methods for calculating the service load of a single-family dwelling. These are the standard method found in 220.10 through 220.88 and the optional method found in 220.82. The steps to calculate the service load of a single-family dwelling using the standard method are: firstly, calculate the general lighting load. This is calculated by multiplying the square footage of the dwelling by 3 volt amps per square foot. Secondly, calculate the small appliance branch circuit load. This is calculated by adding together the volt amps for 2 small appliance branch circuits at 1500 volt amps each. Thirdly, calculate the laundry branch circuit load. This is calculated at 1500 volt amps. Fourthly, calculate the individual appliance loads. This is calculated by adding together the nameplate ratings of all appliances that are rated at 1/4 horsepower or greater. Fifthly, calculate the heating and air conditioning load. This is calculated by taking the larger of the heating load or the air conditioning load. Sixthly, apply demand factors. Demand factors are applied to the general lighting load, the small appliance branch circuit load, and the laundry branch circuit load. The demand factors are found in Table 220.42. Seventhly, add up all of the loads. The sum of all of the loads is the service load. The steps to calculate the service load of a single-family dwelling using the optional method are: firstly, calculate the total connected load. This is calculated by adding together the nameplate ratings of all appliances and equipment that are connected to the service. Secondly, apply demand factors. Demand factors are applied to the total connected load. The demand factors are found in 220.82. Thirdly, add up all of the loads. The sum of all of the loads is the service load. The standard method is more conservative than the optional method. This is because the standard method uses higher demand factors. The optional method is more accurate than the standard method. This is because the optional method takes into account the actual usage patterns of the dwelling. The choice of which method to use depends on the specific circumstances of the dwelling. If the dwelling has a high load diversity, then the optional method may be used. If the dwelling has a low load diversity, then the standard method should be used. Load diversity is the ratio of the maximum demand of a system to the sum of the individual loads of the system. A high load diversity means that the maximum demand of the system is much less than the sum of the individual loads of the system. A low load diversity means that the maximum demand of the system is close to the sum of the individual loads of the system. The NEC provides a table of demand factors for dwellings in Table 220.42. The demand factors are based on the square footage of the dwelling and the number of appliances. The NEC also provides a table of demand factors for ranges and cooking appliances in Table 220.55. The demand factors are based on the nameplate rating of the range or cooking appliance. When calculating the service load of a dwelling, it is important to consider all of the applicable codes and standards. These codes and standards include the NEC, the local building code, and the local utility company's rules and regulations. It is also important to consult with a qualified electrician to ensure that the service load is calculated correctly. The calculation differences between the standard method and method 220.30 in the NEC are substantial and stem from fundamentally different approaches to estimating the electrical demand of a dwelling. The standard method outlined in Article 220 takes a more granular approach, calculating loads for various components separately and then applying demand factors. Method 220.30, being an optional method, simplifies this process by applying demand factors to the total connected load. The standard method requires detailed calculations for general lighting, small appliance circuits, laundry circuits, and individual appliances. General lighting is calculated based on the dwelling's square footage, small appliance and laundry circuits are calculated at fixed values, and individual appliances are factored in based on their nameplate ratings. Demand factors are then applied to these individual loads based on tables provided in Article 220. Method 220.30, on the other hand, starts with the total connected load, which includes all lighting, receptacle outlets, appliances, and other electrical equipment. A demand factor is then applied to this total connected load, often resulting in a significantly lower calculated load compared to the standard method. This difference arises because method 220.30 assumes a level of diversity in appliance usage that the standard method does not. The standard method tends to be more conservative, assuming that a larger percentage of the connected load will be in use simultaneously. Method 220.30 recognizes that in reality, many appliances and electrical devices are not used concurrently, leading to a more realistic estimation of the peak demand. The impact of these calculation differences is most noticeable in the sizing of service entrance conductors and overcurrent protection. The standard method often results in a higher calculated load, necessitating larger conductors and a higher rated service disconnect. Method 220.30, with its lower calculated load, may allow for smaller conductors and a smaller service disconnect, potentially reducing installation costs. The choice between the standard method and method 220.30 should be based on a careful evaluation of the specific dwelling and its anticipated electrical usage. Factors to consider include the size of the dwelling, the number and type of appliances, and the lifestyle of the occupants. In situations where there is a high degree of certainty that the electrical load will be relatively low and diverse, method 220.30 may be appropriate. However, In cases where there is uncertainty about future electrical usage or where the dwelling is expected to have a high electrical demand, the standard method may be a safer and more conservative choice. Local codes and regulations may also influence the choice of calculation method. Some jurisdictions may require the use of the standard method in certain situations, while others may allow the use of method 220.30 at the discretion of the electrical inspector. It is always advisable to consult with the local authority having jurisdiction to determine the appropriate method for calculating the service load of a dwelling. From an engineering perspective, the differences in load calculations arise from the different approaches to modeling the electrical demand. The standard method uses a deterministic approach, calculating individual loads and applying fixed demand factors. Method 220.30, in contrast, uses a more probabilistic approach, recognizing that the actual electrical demand is a function of the probability of different appliances and devices being used simultaneously. While method 220.30 may provide a more realistic estimate of the peak demand in many cases, it is important to recognize that it is based on statistical averages and may not be appropriate for all dwellings. Dwellings with unusual electrical loads or usage patterns may require a more conservative approach, such as the standard method, to ensure that the electrical system is adequately sized. The choice between the standard method and method 220.30 is not simply a matter of choosing the method that results in the lowest calculated load. It is a matter of carefully considering the specific characteristics of the dwelling and its anticipated electrical usage, and then selecting the method that provides the most accurate and reliable estimate of the peak demand. In cases of doubt, it is always better to err on the side of caution and choose the more conservative method to ensure that the electrical system is adequately sized and safe.